construct. You can use construct, but or you should be using your compass and your actual straight edge. It's easier for me to use this. First thing we need to do is we need to draw an angle. Here's my angle. Draw yourself an angle. Okay. The goal of this construction is that I will bisect this angle. So I'm going to cut my angle into two congruent parts. First thing you want to do, we're going to take our compass, put your dagger on the vertex of the angle. Now, I don't care how big you make it or how little. We're going to make our compass setting and we're going to make an arc that passes through both sides of our angle. That should be step one of your construction. I have angle ABC. I put the dagger of my compass on the vertex of the angle and I make one big arc that passes through both sides of my angle. That's step one. I would like you to put a point where the arc and your side of your angle intersect. Put a point where the arc and your angle intersect. All right, next. So far, angle was drawn, vertex had the dagger, and I made one arc all the way through. I'm going to take my compass again. This time I'm going to move the dagger onto one of those points. It does not matter what your compass setting is. So I'm going to make mine like this. I am going to make an arc. Okay. So this blue one. Now what matters is after I make that blue arc, do not change your compass setting. I'm not going to change it. But I'm going to move my dagger over to the other point that I just drew. I did not make my compass bigger or smaller. So this is my dagger on this point, and I make an arc. There it is. This is the magic point where both of those two arcs intersected. That's what I'm looking at. If we draw in this segment, we have bisected our angle. So that's the actual construction. Pretty cool. We're going to talk about why this construction works. So give me a sec. Oh, made it too small. All right, here we go. So what we're actually going to talk about today is writing our first two-column proof. Woo! We can do it. So over here for a two-column proof, I want a solid line. I want no arrows. It's legit, 2 columns. The first column is labeled statements. And the second column is labeled reasons. Think of it like a sentence. The word because can be in the middle. So let's go back to our construction. The first thing we did was we put our dagger on B and we made one giant arc that passed through both sides of the angle. I'm going to put a tick mark on BD and a tick mark on BE. So the question you have to ask yourself is, why do I know segment BD is congruent to segment BE? Did I make that up? I don't think I made it up. But let's talk about what we're doing with that compass. A compass can only draw circles. So if I put the dagger here, if I continue drawing this all the way around, right, it would have been just a plain old circle. And living in this red circle, BD and BE would have been radii. So any radii in the same circle have to be congruent. That's a good answer. I can say segment BD is congruent to segment BE because radii of the same circle are congruent. Let's move this out of the way. All right. let's talk about the next thing we did during our construction. So after we had our first arc, our second arc, we put our dagger on D and we made an arc of any size. The important part here is once we picked our dagger up off D, we put it on E and we made another arc. I did not change the compass setting. Oh, I need my line tool. I did not change the compass setting. So by not changing the compass setting, let's think about what that is. If D is the center of my circle and I made this blue arc, DF would be a radius of that circle. Okay? If I do not change my compass setting, I put the dagger on E and I make the arc this way, EF would be a radius of this circle. But because I didn't change the compass setting, those radii would be congruent. So I can say that segment DF is congruent to segment EF because congruent circles have congruent radii. And again, I know, no question, these are congruent circles with congruent radii because I did not change the compass setting. So I can put tick marks on those that tell me that segment DF is congruent to segment EF. Next, you guys can kind of see this pink, red, blue triangle over here, pink, red, blue triangle over here. We're ultimately getting to showing these triangles are congruent. The third segment in the triangles is segment BF. Whoa, pump the brakes. Why can I say segment BF is congruent to segment BF, and who gives me the power to say that? Well, look, segment BF lives in the top triangle, segment BF lives in the bottom triangle. So because segment BF lives in both, I can say it's congruent to itself. We have a special fancy property name for that. We say segment BF is congruent to segment BF. That is because of the reflexive property. There we have it. So, in order for shapes to be congruent and our figures to be congruent, everything about them has to match up. The segments, all the corresponding sides have to be congruent to each other, and all the corresponding angles have to be congruent to each other. But you know, we're mathy peeps, so we have shortcuts. Our first shortcut is side, 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 right? That means if I have 3 sides of one triangle congruent to 3 sides of another triangle, that's enough. Without knowing all the little tidbits about it, that's enough to say the triangles are congruent. So if I look, I have 1 pair of sides congruent, a 2nd pair of sides congruent, a 3rd pair of sides congruent. And again, 3 pairs of congruent sides is enough. It's our shortcut. It's our first shortcut of the year to say that these triangles are exactly the same as each other. So I'm going to say triangle BDF is congruent to. Now, again, if I talk about congruent triangles, the way I name them, their matchy-matchy parts have to line up. So if I say triangle BDF, it has to be congruent to triangle BEF. And we say that is because of side, 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 which I'll write up in a minute. So the 3 sides of this triangle are congruent to the 3 corresponding sides of this triangle. That's enough to say these triangles are identical. If the triangles are identical, that means their matchy-matchy parts are also identical. Wow. So if their matchy-matchy parts are identical, I can say this angle down here is congruent to that angle over there. So that is angle DBF is congruent to angle EBF. Why do I know those two are congruent? They're matchy-matchy parts of congruent triangles. But in math class, we like to say corresponding parts of congruent triangles are congruent. One more time. Corresponding parts of congruent triangles are congruent. So if I know these two angles are congruent, we have shown that segment BF bisects angle DBE. How do we know that's happened? We learned the other day what the definition of bisect is. So we know that happened because the definition of bisects. Ooh, we had some big things in here. All right, let's write them down together. So here we go. We learned what is side, side, side. So if we have three sides of one triangle and they're congruent to the three corresponding sides of another triangle, that's enough to say these triangles are identical. Even though I know nothing about the angles, this is our first shortcut. And we call it side, side, side because we know the two sides. And after we use side, side, side today, we use CPCTC. That stands for corresponding parts of congruent triangles are congruent. I should write out the word. Corresponding parts of congruent triangles are congruent. So once we know the triangles are the same, that means their matchy-matchy parts are also the same. So that is our construction for can I bisect an angle, and that is our proof for can I bisect an angle. Thanks. It'd be great if I could stop it. Ooh, stop.